Hey everybody, let's get into some fraction action, and we're going to introduce a new math animal. That's right, get ready with all your markers. Here we go. A review of fractions. Yes, here we go. Here's some, it's going to be a fraction review, and we're going to focus on some word problems. And in order to help us, let's get out a new character. I know you guys you're pretty pumped. So here's our new character, never been introduced before. And here we go. It's a very Canadian character. So I know what you're thinking. It's going to be Math Bear again. No, it's not going to be. What are we going to have here? Well, we need little arms. Oh, there he is. And that kind of stuff. And little paws. So you're wondering, like, ooh, what's this little guy going to be? And we'll get little paw prints. So, you know, fraction is going to be a lot of excitement today as we review some adding, subtracting, multiplying, and dividing. And in order to help us, here we go. Let's kind of color those in. Nice little big cute eyes. Big cute eyes. And we need big cute eyes because, here we go. We should be able to figure this out now. There we go. And let's get some teeth in there because the teeth are the key. And of course, who is this going to be? Who's this going to be? It's going to be, can you guys see it now? It's going to be Math Beaver. That's right, Math Beaver. Great Canadian Math Beaver. There we go. He can build dams, and he can do some math as well. Okay, so we got Math Beaver going on. He's going to be helping us today. So, a couple of things. When you're adding and subtracting. When you're adding and subtracting, what do you need? You need common denominators. So common bottoms. Right, Math Beaver? So let's get an example. Here's your example. Let's do 7/9 plus a half. So 7/9 plus a half. This is how I like to write it. You want to think of what is the LCM of 9 and 2. So what is the LCM of 9 and 2? The quick and dirty way for kids is just to multiply. So just multiply 9 times 2. Of course, you're going to get 18. How I like to write it is this. One giant line. I put my common denominator on the bottom. And sometimes when I'm first teaching this, I'll show kids with these arrows. So 9 times what is 18? Of course, it's times 2. And then you go 7 times the 2, which is going to give you 14. You do on the other side, 2 times what is 18, it's going to be 9. So 1 times 9 is going to give you just 9. And of course, we are adding. So we're adding. So our final answer, and I'm going to do final answer in pink, is going to be that 14 plus 9. So we're going to get, what, 23? 23 over 18. And there's your final answer. You leave it as an improper fraction because, let's be honest, improper fractions is the best. What about multiplying and dividing? What about multiplying and dividing? Well, for these, you know that you are going, my saying is you're always multiplying. So you're multiplying across the top. Oops, there you go, across the top and the bottom, And the second thing I like to always emphasize is you want to reduce. Actually, you want to cross-reduce. Cross-reduce and simplify. And simplify. That's what you want to do. For my cross-reduce, I always have kids do an X with their arms. So if you're at home right now, you can do like across your chest, just cross your arms, and then if you're into Marvel, you say Wakanda forever. So you cross your arms to remember to cross reduce, and then you also simplify. Let's see some awesome examples. Let's do 18 over 24 times. Well, let's do something crazy like, I don't know, 40 over 68. These are giant numbers. What? Giant numbers. So right now, so again, you can cross-reduce. You cross-reduce on the x. So you look at those two numbers, 24 and 40, and ask yourself, is there a common number that you could divide by? And you're like, yes, I could divide by 4. And yes, I could divide by 4. Tiny little 4. And what does that give you? So that would give you 10. And that would give you what? 6. Sweet. You can keep going though, can't you? Yeah, for sure. Let's divide this by 2. And you get 5. And whoo, you get 3. And then maybe we look at the other x, 18 and 68. And let's say, let's divide by 2, because they're even numbers, so they're dividing by 2. So 9 and 34. And then you say, is there anything else? Oh my gosh, there is. We're going to simplify this part. 9 and 3, divide both by 3, so I get 3 here, and then just 1 right here. So what is now our brand new equation? It is going to be 3 over 1 times 5 over 34. Whoa, oops, there we go. 5 over 34. So again, multiply across the top and across the bottom. So it looks like this, 3 times 5 over 1 times 34. Oops, 1 times 34. And you get 15 over 34. Final answer, boom. Off you go. Let's take a look at dividing. So when we're dividing, you want to, where's my colors going? Where's my colors? There you go. So when you're dividing, what's the little saying? Is it keep, change, flip? Is it keep, change, flip? Is that the saying that all the math teachers always use? Keep, change, and flip. I think that's how the video goes. There's a whole rap video if you look on YouTube. Keep, change, flip. I showed it to my kids and they seem to really, really like it. So what do I mean by that? Oh, here we go. Let's say you had, I don't know, 5/8 divided by, let's divide it by 7/9. That'll be fun. So keep. So I'm going to keep this. I'm going to change this. And I'm going to flip this. That's what we're going to do. So here we go. Let's go and do that. So I keep my 5/8. I change dividing into multiplying. And then I'm going to flip this so it becomes 9 over 7. Flip, what's the key word? It's actually reciprocal. Okay? That's a fancy word. And then we're going to go and do it. So we get 5 times 9 and 8 times 7. Noticed how I made sure that there was no simplifying or cross-reducing possible. Fantastic. It's like I'm a professional math teacher. 45 over 56. And I think there is nothing that can simplify that. And there you go. So keep, change, and flip. Now let's go into a common kid mistake because I love the common kid mistake for this one. Do you want to see a KKM? For those of you not familiar with the Math Jedi, we do KKMs, common kid mistakes. Think about that for a while and see why we call it the KKM. But the common mistake is this. Let's go and do 12 over 20 divided by, we'll make it very tempting, 40 over 50. Here is a common kid mistake waiting to happen. Just imagine you're sitting at your math test and you turn over the page and you see this question and you're like, oh my gosh, I remember. It was keep, change, flip. And then he kept talking about simplifying and reducing. So kids get super excited and this is what they do. They look at this and they go, oh, I know. I can divide this by 20 and I can divide this by 20 and oh, this is awesome. And then they say over here, oh, I can divide this by, let's use a different color. I can divide this by 2 and this by 2. Oh, this is going to be great. And what the kid does, he says, great, so now it's 6 over 1 times 25 over 2. Oh, this is going to be great. I'm going to go and simplify even more. And I'm going to say this is 1 and this is 3. This is going to be great. And my answer is 75. I'm a math genius. That's right. They get so excited. They're like, oh boy, let's try a math beaver. Math beaver, there he is. So remember, the key for math beaver is just really it's the upside down triangle and the little teeth. Okay, that's the key. And then obviously the giant tail. That's really the key for math beaver. Anyways, so what happened? Why was that a common kid mistake? Because you must do the keep, change, and flip first. Keep, change, flip first. You have to do this first. Because you can't just go and cross reduce until you go and do keep, change, and flip. Because look what happens. Let's do the exact same question. Let's go back in time. And now, this is I'm a student who said, oh wait, I'm going to go and keep, I'm going to change, and I'm going to flip. So they're going to do this. So they did all that first, and look what happened now. Things have changed. I'm going to divide this by 10, and this by 10. And over here, I'm going to divide this by 4, and this by 4. And now, look what I get. I get 3 times 5 over 2 times 10. So I get 15 over 20, and I'm an awesome student. I'm going to continue to divide the top and the bottom by 5, and my answer is 3/4. It's a lot different than 75, isn't it? Don't fall for the common kid mistake. Okay, so we're looking at word problems, and if we're looking at word problems, let's get into some classic things like Billy. So we have Billy the Beaver, and we know Billy the Beaver, he loves maple syrup, and he has 2 3/4 bottles of maple syrup. This is going to be fantastic. 2 3/4 bottles of good old Canadian maple syrup, the home of maple syrup and pancakes. And luckily, Billy the Beaver, he has, let's say, 3 friends. He has 3 friends. And here we go. If he divided the syrup equally, so if you went, Billy the Beaver, if he divided the syrup equally, how much would each get? Comma. And this is a tricky question for a reason I'm going to talk about in a second. How much would each get? Now, this is a classic question. And here we go, little star in your notes. What you got to clarify is, does this include Billy? Does it include Billy? Because sometimes teachers will only have it divided amongst their friends and Billy gets none. So this is something you should always want to clarify. So basically with this one, this is going to be a dividing question. This is a dividing question. Okay, so that's what we have to kind of realize. So you're going to be going and just doing the following. So you get 2 3/4, so that's syrup. And we're going to divide it by the 3 friends. I will just say though, it could be 4 if we included Billy. But for our example, we're not going to. So what are we going to go and do? We're going to go and convert this into an improper. So 2 times 4 plus 3. So that's going to give us 11 over the common denominator of 4. And remember, it's keep, change, and flip. So this is 11/4 divided by 3. I love to make all my whole numbers over as fractions. So I'm going to go and keep, change, and then flip. So this actually becomes, a little error, 11/4 times 1/3, which is just going to be basically 11/12. So each person gets 11/12 of a bottle of Canadian maple syrup. Now, not only are we going to talk about Canadian maple syrup and beavers, well, you know, what else does Billy the Beaver like to do? Well, Billy, you know, he has, what else does he like to eat? He has, we're going to say 2/3 of a cake. Ooh, he has 2/3 of a cake. And he eats 1/4 of it. So he eats 1/4. I'm going to change my font color of, why did I do that? Of the cake. And how much is left? How much is left? Now this is it's a crazy question, so here we go. A couple things. The word of. What does it mean in math? In math, it means multiply. So this is a multiplying question. And also, left, okay, I'm also going to highlight that word as well, because that's going to come into it as well. So if you have 2/3 of a cake and you eat 1/4 of it, you eat 1/4 of the cake. So what I'm meaning here is Billy's eating 1/4 of what's left right now, so 2/3 of the cake. So he's eating 1/4 of it. So this is 2/3 of means multiply 1/4. So this is what he goes and he eats. So this would become 2 times 1, so 2 times 1 over 3 times 4. So that would just equal 2 over 12. And you'd probably simplify that, right? You're a good kid, you got to simplify to 1/6. So he eats 1/4 of it. So how much did he eat then? He ate 1/6. He ate 1/6. But I asked how much is left. So this is always kind of tricky for kids. Is it what is left of the entire one whole cake? Or is it what's left after the 2/3? Does that kind of make sense? The two different kind of situations. So one could be, 1 minus 1/6. Or maybe it's 2/3 minus 1/6. This is starting from the original cake and eating 1/4 of the 2/3. Or this is the 2/3 of the cake is left and then they went and ate 1/4 of it, which is 1/6. Typically, it's this scenario here, which is what we're going to go and do. So if we have to go and do this one, we need common denominators because we're adding and subtracting. So we're going to make everything over 6. And what we're going to end up doing is that 2/3 becomes 4/6. So we end up getting 4 minus 1. So that is going to be 3/6, which simplifies to 1/2. And that is how much is left over. Let's multiply Billy. And let's get a whole bunch of them, all right? So we're going to say there are 125 beavers. Pretty exciting. So there's 125 beavers. And we're going to say 1/5 of them they like ice hockey. Okay, so you got some hockey-loving beavers, which is pretty cool. So 1/5 of them like ice hockey, and then we're gonna say of that, so 1/5 of the beavers, of the 125 beavers, they really like ice hockey, and of those 1/5, so of the 1/5, we're gonna say of that 4/5 play hockey. Ooh, this is going to be a great question. How many is that? So how many beavers is that? So how many is that? Okay, so there's the question. There you go. So we're talking about some hockey, which is pretty cool. I love hockey. Whoop, there we go. There's my hockey stick. And there we go. Being from Canada, you kind of basically have to like hockey. So this is what we're doing. You see that word there? What do we talk about? The word of, which means multiplying. Yes. So hopefully you guys got that. So we're doing 125, and I always put whole numbers over 1. Of means multiply times by 1/5. 1/5. So there we go. So that's the very first part of the equation. So we're going to do our cross producing. Going to divide this by 5 and this by 5. Ooh, what's that one? What's 5 into 125? I think it's 25. I think there's 25 fives, right? Is that right? Yeah, that's right. So we get 25 times 1 and 1 times 1. So that's going to equal 25 over 1. So there are 25 beavers that like ice hockey. Well, that's cool. It says of these 25, 4/5 they play hockey. 4/5 of them. So there's that of word again. So we're going to multiply that 25. We're going to times this by 4/5. Again, we're going to go and cross reduce. So this goes in, 5 goes into 5 once, and 5 goes into here 5 times. So 5 times 4 is 20. So there are 20 beavers that play ice hockey that also really like ice hockey. So sometimes we're going to ask you to figure out how much of things there are. So that's an interesting way to kind of go about it, and realizing that word of means to multiply.